Analyze the balanced chemical equation. The given equation represents a redox reaction in acidic solution. MnO4 to the power negative plus 5 Fe to the power 2 plus 8H to the power plus gives Mn to the power 2 plus 5 Fe to the power 3 plus 4H2O. Identify the stoichiometric coefficients of the species of interest. Locate the coefficients for each reactant and product. Permanganate ion, MnO4 to the power negative 1 iron, 2 ion, Fe to the power 2 plus 5 hydrogen ion, H to the power plus 8. Iron, 3 ion, Fe to the power 3 plus 5 water, H2O4. Set up the mole-to-mole ratios. Use the coefficients to write stoichiometric conversion factors between the reacting MnO4 to the power negative ions and the other species, with Fe to the power 2 plus 1 MnO4 to the power negative over 5 Fe to the power 2 plus. For every 5 Fe to the power 2 plus ions consumed, 1 MnO4 to the power negative ion reacts with H to the power plus 1 MnO4 to the power negative over 8H to the power plus. For every 8H to the power plus ions consumed, 1 MnO4 to the power negative ion reacts with Fe to the power 3 plus 1 MnO4 to the power negative over 5 Fe to the power 3 plus. For every 5 Fe to the power 3 plus ions produced, 1 MnO4 to the power negative ion reacts with H2O, 1 MnO4 to the power negative over 4 H2O. For every 4 H2O molecules produced, 1 MnO4 to the power negative ion reacts. Relate the quantities algebraically. Number of MnO4 to the power negative ions equals 1 over 5 times number of Fe to the power 2 plus ions consumed. This matches option A exactly. The correct answer is option A, 1/5 the number of Fe2 plus ions that are consumed.